more over this one. And Edgar's in class.
Nope, only one today. All right.
We'll see if that camera wakes up. There we go.
Thank you.
Thank you.
No more big screen. Oh, these are big.
Hey.
Hey, Sudan, can you see me?
Yes, can you hear us?
I can hear y'all.
Okay, we pulled in our old ITV system so we could get these kids back on class.
Awesome. Yeah, I'm glad they get to see my beautiful face now.
Yeah, they were missing you.
They were missing me and my beautiful beard.
Yeah. Yeah, we had the service center come out and Matt got us going again. We moved this from our old room back down, so we'll be set up, ready to go.
Awesome. Well, I'm glad that technology issue has been resolved. I know we're all frustrated about that.
Yeah, it was the inconsistency that was getting us. Some days it was great, crystal clear, and then most days we were just hearing you.
Well, they keep on talking about how they're going to get new stuff. When that happens, I don't know.
Yeah, I'm expecting January now.
You might be more optimistic than me.
No, it's gonna be good once it's all in. It's pretty cool stuff. Now it's on. Okay.
Okay. Well, it's close enough to time to get started. Welcome everybody. Sudan, I'm glad to know that y'all have figured out or resolved the technology issue, made a workaround, and so glad you are back up to speed. So what's going on today? We are going to continue to deal with any questions that you have, specifically over assignment 20, exponential equations, though I'm open to answering questions over any of the assignments, future or present or past. The floor is yours, so to speak. Let's see, announcements. We'll have a quiz on Friday. And I have to decide, as of now, the exam 3 is still set to be on Monday and Wednesday of next week. I just haven't put in the thought time to decide if I want to change that to Wednesday and Friday of next week. The only reason that I would change it to Wednesday and Friday of next week would be to give you the option on Monday to address any questions that you might have over any lingering topics. That could be a good idea. I guess I just need to put in that thought process. So, as of now, it's still set Monday and Wednesday of next week. Again, that's tentative. It could change just depending on how I am swayed by what I'm considering. Anyways, that's enough of that. We will have a quiz on Friday. That quiz will be over material up through today's assignment, assignment 20. You might have lingering questions over assignment 21, so I don't want to give any a quiz over any lingering questions from assignment 21. So let's just open up the floor to questions that you might have over assignment 20 or anything previous. I know yesterday there was a question I started that I didn't get quite finished with. I think that was 16. I do want to go over that, but let me potentially build up to that. Is there anything before assignment 16, any questions over previous problems that we need to look at? Any questions?
Can you do number 18?
18. Sure. So, since I started 16 on Monday but didn't get to finish it, how about I go ahead and do 16 in case anybody's still lingering over that, and then I'll do 18 because 16 and 18 are going to be very similar to each other. Does that sound okay?
Yes, sir, that's fine.
Okay. So, that looks funny. Has a bluish tint. I don't know why. I wonder if it's because I don't have all the lights on. No, that didn't do anything. Oh well, we'll just interesting color. That doesn't help. All right. Oh well. There we go. Alright, so let's just go back and do problem number 16 from assignment 20, which is dealing with exponential equations. Problem number 16, we have e to 2x minus 2e to the x minus 3 is equal to 0. And as I began on Monday, I stated that this is can be expressed as a quadratic type equation. And the way that we recognize that is we recognize that e to the x, if you square it, you get e to the 2x. So what that means is that if I let u be equal to e to the x, then u squared becomes e to the 2x. And what I get to do now is I get to use these substitutions to rewrite this equation up here. I can now rewrite it as u squared minus 2u minus 3 is equal to 0, which there is your quadratic equation. So now I'm going to solve this quadratic equation like I normally would. I'd probably factor this. So factors of -3 that add to -2. How about a -3 and a +1? Which then means that u is going to be equal to +3, and that should be a u. And u is equal to -1. Then we'll come back and we'll use our expression for what is u. U is, since u is equal to e to the x, we have e to the x is equal to 3, and e to the x is equal to -1. Now, right now, I can already throw out one of these answers. I can already throw out e to the x equals -1 because the reason is because the domain of, or excuse me, the range, I should say range, the output values of some b to the x is going to be, it's always going to be greater than 0, and it's going to get up to infinity. Basically, the output of any exponential function is always going to be positive. Maybe that's a better way to put it. The output of b to the x is positive. And also greater than, positive. Alright, so that leaves me with just having to solve this guy. So if you've gotten this far in the notes, you know what to do from this point. To get that x out of the exponential position, we take the natural log on both sides. And that's going to allow me to use the power rule. So I'm using the power rule right here to bring that x down out in front of the natural log of e. And there's a nice little property that we realize that the natural log of e is just 1. So you have x times 1 is equal to the natural log of 3, which gives us that x is equal to the natural log of 3. And we're done. This is the exact answer that I want. You'll notice that in the answer key, I gave you the approximate answers, but when I say give me the exact answer, I want the exact answer, and yeah, you can use your calculator to approximate this to, 4 decimal places or whatever. So, I know that somebody asked about problem number 20 on Wednesday. If you still had a question over problem number 20, does this resolve any questions over problem 16? Are we good with problem 16? Yes? No?
We are.
Okay. Alright, I saw a thumbs up. Okay. So let's go and look at problem number 18. And problem number 18 is going to be very similar. Well, I say that. Let's see what happens. Let's see, what would I do first? I said it was going to be similar, but I'm mistaken because there is no e to the x. If there was an e to the x in here, I would say that it would be quadratic in form, but there is no e to the x. All I have is an e to the 2x. So I think what I'm going to try to do is I'm going to try to isolate as much as I can e to the 2x. Because if I can isolate e to 2x, then I can take the natural log of both sides to get this 2x out of the exponential position. So let's see what we can do here. I could add 5 to both sides. So that would give me 7e to 2x is equal to a 63. Oh, and I can divide both sides by 7. And that gives me e to 2x is equal to 9. Okay, so now I'm still trying to get x by itself. Now, x along with the 2 is way up there in the exponential position. So, just like I did over here, I took the natural log of both sides, which I get to apply the power rule to bring my exponent out in front. I'm going to do the same thing. We're just going to take the natural log on both sides. So natural log of e to 2x is equal to the natural log of 9. Then we'll use our power rule and we'll bring all of 2x down. So again, we're using the power rule here. So this gives me 2x times the natural log of e is equal to the natural log of 9. Again, the natural log of e is just equal to 1, so this just gives me 2x is equal to the natural log of 9. And then to get x by itself, I'm going to divide both sides by 2. Now, it's important to realize that the natural log of 9 is one thing. We can't take 9 and divide it by 2, because the 9 is within this natural log function. So all we can say here is that x is equal to the natural log of 9 all divided by 2. And there is your exact answer. There is your exact answer. Alright, so does that answer any questions over problem 18?
Yes, sir. Thank you.
You're welcome. Alright, what else can we look at? Alright, so I kept on getting this wrong the other day, so I want to make sure I get it right. The other class that I'm seeing looks like I got at the end of the table two a student and maybe another student working together. Looks like a pink folder at the end of the table. Is that Plains? Is it Plains that I'm seeing? Or is it post?
It's post.
Post. Post. Okay, how are y'all doing, post?
Good, and you?
I'm doing well. Is there anything I can help y'all with?
Can we do question 10 on assignment 21?
Alright, so question what now? Say that again, please.
Can we do questions on
You cut out.
Can we do questions on assignment 21?
Sure, what do you want to look at?
Number 10, please.
Problem number 10. We have the log base 2 of x minus 1 minus the log base 2 of x plus 3 is equal to the log base 2 of a 1 over x. Okay, so when I'm looking at this problem, I see too many terms. I have too many logarithms. So what I want to do is I want to begin condensing these logarithms. Now, before I begin condensing these, you might be thinking, oh, I need to set this equal to 0, and that way I can put all three logarithms into one logarithm. Well, I want you to hold off on that thought if that's what you're thinking, because this is what's about to happen. We're about to see the log base b of, let's call it big A, is equal to the log base b of a big B. We're about to get to the point where we're going to have a logarithm on one side with the base of b. It's going to be log base b of something. And on the other side of the equation, we're going to have a log with the same base of something else. And if you're ever in this situation where you have log base b of a equals log base b, so you have the same b, so something else, then big A has to be equal to big B. So I don't know if you saw that, but I just want to emphasize that because we're about to see this situation in this problem. So I'm going to start off by condensing these two logarithms because of the minus sign with my quotient rule. We're going to condense those two logarithms using our quotient rule. So this becomes the log base 2 of, in the numerator I have x minus 1, and my denominator I have x plus 3, is equal to the log base 2 of a 1 over x. And now, do you see it? We have a log base 2 of something equals the log base 2 of something else. Since these have the same base, we now get to say that x minus 1 over an x plus 3 is equal to a 1 over x. Alright, and now we need to solve. Now I need to solve. I'm going to make a quick statement right here. I know that when I solve that x cannot be equal to negative 3 and x cannot be equal to 0. You cannot have those values. I guess really we should look up here to figure out what x cannot be. Back up here you can't even have x equal to 1. Because that would be saying 2 to what power is equal to 0. So remember, you cannot take the logarithm of 0. So even up here, I could say that x cannot equal 1, x cannot equal negative 3, and x cannot equal 0. I'm just keeping that in my back pocket. So let's go through and solve this. How am I going to solve this problem right here? Well, I guess one thing that we could do is we could cross multiply. I can multiply these two guys together, and then I can multiply these guys together. And that will get everything out of my denominator position. So that's going to give me x times x minus 1 is equal to 1 times an x plus 3. So basically what you're doing is to make the x go away in your denominator here, you multiply both sides by x. Well, the x over here is going to cancel out with that x, so you get x times the x minus 1. Same idea over here. To get rid of the x plus 3 in your denominator, you multiply both sides by x plus 3. Cancels out over here on the left, but then you have 1 times the x plus 3. And then we get x squared minus x equals x plus 3. Then I will set this equal to 0. So I'm running out of room here. Let me just rewrite what I have. Well, let's just go ahead and set it equal to 0 real quick. We can subtract x, subtract 3, subtract 3. So that's going to give us, I gotta go to my next page, x squared minus 2x minus 3, is that right? X squared minus 2x minus 3 equals 0. Then we're going to solve this quadratic equation. How do we solve quadratic equations? Like these to be engineered so that you can factor them. So factors of negative 3 that add up to a 2. How about a negative 3 and a positive 1? Which then means x is equal to 3 and x is equal to negative 1. But what did we say? Over here, oh, yeah, you gotta be even more thoughtful about this. You gotta be even, so you gotta check your answers. Make sure that you check your answers. C-H-E-C-K. Check. So, because there's something I'm seeing here that I didn't see or I didn't recognize at the very beginning. When we go back into the log base 2 of an x minus 1 minus the log base 2 of the x plus 3, equals the log base 2 of a 1 over 0. So something that we have to remember, something that you have to be thinking about. For the log base b of u, okay? U cannot be equal to 0, and U cannot be, U must be greater than 0. Try it out with your calculator. Try to take just the log of a negative number. So a natural log of a negative 2. Natural log of a negative 2. Domain error. You can't plug in a negative value. Even if you do natural log of 0, clear 0, domain error. You cannot take the logarithm of a negative number. So what I need to do is I need to check these answers. And I'm fairly convinced that I've done everything correctly. So I'm just going to look. Can I plug in 3? Well, 3 minus 1 is 2. That works out. 3 plus 3 is 6. That works out. And 1 over 3 is 1/3. I can take the logarithm of 1/3. 3 seems to check out. But negative 1, if I do negative 1 minus 1, that's a negative 2. I cannot take the log of a negative 2. So because of this right here, I get to throw out that answer. Now, to check this without a calculator, here's what I would do. For x equal to 3, we have the log base 2 of a 3 minus 1 minus the log base 2 of a 3 plus 3 is equal to the log base 2 of a 1 over 3. So we have the log base 2 of 2 minus the log base 2 of 9 is equal to the log base 2 of a 1/3. I'll use my quotient rule. So we have the log base 2 of a 2 over 9 is equal to, oh sorry, that's not 9. I'll probably look at me like, where does he get that 9 from? 3 plus 3 is 6. Is equal to the log base 2 of a 1 over 3. And if I simplify 2 6, we get the log base 2 of 1/3 is equal to the log base 2 of 1/3. And I can evaluate the log base 2 of 1/3 because 1/3 is greater than 0, and it's not 0, so this all fits within, you can say that 1/3 is in the domain of a log base 2 of x. So does that make sense why x equal to 3 is our only answer for problem number 10? Does that make sense why? Yes or no?
Yes.
Yes. Okay. Anybody needs further explanation? Post, are y'all good? Okay.
Sorry, I accidentally pressed on the button.
I heard you. How else can I help y'all? Any other questions we can look at? Back to assignment 19, perhaps? Or 20?
Could you help us on number 2 on number 19?
Number 2 on problem number 19, or assignment 19. Assignment 19? Is that correct?
Yes, sir.
Problem number 2. So, let me, is that what we're looking at? Is that the problem that you're asking about?
Yes, sir.
Okay. So I'm going to do this the way I think I presented it in the notes. Then I'm going to show you what I think is just a shortcut. So again, I don't remember, it's been so long since I made these videos, but I probably approached this going 2 logarithms at a time. And since I see the plus sign right there, I'm going to know that I'm going to use the product rule. So that means I'm going to have the natural log of x times y minus the natural log of z. I mean, I could rewrite this as natural log of xy minus the natural log of z, but I think we get the point. Then to condense these two guys, since there's that minus sign, I'm going to use the quotient rule. So we have the natural log of, here's my division bar. In my numerator, I put the xy, and in my denominator, I put the z, and we're done. Now, this is a shorthand way to look at this, and I'm going to give you the shorthand way because I think this is if I gave you this question on a quiz or a test, I mean, it wouldn't be worth a whole lot of points, because I think the process is pretty straightforward. Notice that in the numerator, the top, we had the natural log of x, which was positive, and the natural log of y, which is positive. And in my denominator, in the bottom, we had the natural log of z, which because that minus sign was negative. So all the things that were positive went up top, and all the things that were negative went down below. Does that always hold true? Well, sure. Sure it does. Suppose I had, so let's call this 2 plus. Suppose I had the natural log of x minus the natural log of y plus the natural log of z minus the natural log of w. Well, if I went through and did this from left to right, well, I'm just going to go ahead and declare that the answer to this is the natural log of what's positive, the x and the z. What's negative, the y and the w. I'm just going to declare to you that that's the answer. Now let me prove it to you. If I condense these two guys, there's a quotient right there, so we have the natural log of x, y, minus the natural log of z, or excuse me, plus the natural log of z, minus the natural log of w. Then condense these two guys, there's a plus sign right there. So that's going to become the natural log of xy times z, which, just to clarify, that is the natural log of xz over y minus the natural log of w. And now to condense these two, because of the minus sign, we're going to use the quotient rule. So we have the natural log of, here's your division bar. Up top you have the xz over y. Down below you have the w. We need to simplify this complex fraction. To simplify the complex fraction, we're going to think of that as a w over 1. We're going to bring it up to top, but flip it. That's that keep, change, flip process for fractions. So we have the natural log of xz over y times 1 over w, which is the natural log of xz over yw. And isn't that what I declared to you was going to be the answer? Xz over yw. And how did I know that? Because all the positive logarithms go in your numerator and all the negative logarithms go in your denominator. Did anybody make that correlation with going through these problems? Did anybody see that? Ah, some people did. I see those thumbs ups. Those thumbs ups. Cool. All right, what else can we look at? Are y'all doing all right with the homework? So I see some thumbs ups from Post. Are y'all done with assignment 20? I guess it is. Are y'all done with assignment 20? Thumbs up. Thumbs down. Not done. Can I help you with any questions? Or does it make sense? Sudan, how about y'all?
We finished assignment 20, but we're doing good.
All right. Yeah.
I have a question over things being quadratic in type.
Yes.
Will we ever have a problem where there's not a solution?
Sure.
Okay.
Sure. So, I mean, I could create a like so. Yeah, sure. So take a look at this example. Um, suppose that you had. So this is just a suppose. You had e to 2x plus 5 e to the x plus 6 equals 0. Alright? Well, because I see the 2x and the x as exponents for e, if I again let u be equal to e to the x, then u squared becomes e to 2x. We now get u squared plus 5u plus 6 is equal to 0. Okay, well if I factor that, that becomes, what are the factors of 6 that add up to 5? How about a positive 2 and a positive 3? Which then means that we have a u plus 2 is equal to 0 and a u plus 3 is equal to 0. Which means we have e to the so back up. That means we have u is equal to negative 2 and u is equal to negative 3. Which then I'm going to plug in my substitution. So that means we have e to the x is equal to negative 2 and e to the x is equal to negative 3. And this is like asking e to what power equals a negative 2. Well, since the range of e to the x is everything from 0 to infinity, and we're talking about the range. This is the output values. Since the range of e to the x is from 0 to infinity, and we're declaring that e to the x can be equal to a negative 2 or e to the x can be equal to negative 3, well, that's a contradiction. So that means that there is no solution. There is no solution to this problem. Now, does that make sense? I mean, even if you take it to the next step, if you take the natural log of e to the x is equal to the natural log of negative 2, and then use the power rule to bring down the x, and even declare that natural log of e is 1, x is equal to the natural log of negative 2. I mean, just try typing in the natural log of negative 2 in your calculator. It does not exist. So you can't have e to the x equal negative 2 or negative 3, so since that's a contradiction, that's no solution. Does that make sense?
Yes, sir. Thank you.
And even graphically, let's just take a moment to look at this graphically. Desmos. So, let's see, functions, miscellaneous. Do I have my, I wonder if it recognizes E. Yep, E raised to the 2x, okay? And then plus 5e to raise to the 1x plus 6 plus 6. Alright, that's the graph. If y'all can see that. That is the graph. Now, when we talk about the solutions to a function, we're talking about where the graph crosses the x-axis, and you can see that this graph never ever crosses
Your
the
conference is scheduled to
x-axis.
end in 2 minutes.
Never ever crosses the x-axis. Does that make sense?
Yes, sir. Thank you.
You're welcome. So, 2 minutes left. We'll have a quiz on Friday up through this assignment. I'm reserving time on Friday to address any questions over assignment 21, logarithmic equations. And I'm going to give y'all a question, and just note that this is not a vote. This is just a poll. This is a, what do you think? What would y'all prefer? This is a poll. This is not a vote. This is a poll. What would y'all prefer? Exam on Monday and Wednesday, or exam on Wednesday and Friday?
Wednesday, Friday.
Wednesday and Friday.
Okay? 2 people said Wednesday, Friday. There's more than 2 people in this class.
Wednesday and Friday.
Wednesday and Friday.
Wednesday and
Friday.
Wednesday and Friday.
What they said.
Alright. This is just a poll. It's not a vote. I'm just going to be taking that into consideration. I will let you know my
Your
final
conference is
decision
now over. Goodbye.
either by email today or tomorrow. Y'all take care. I'll see y'all on Friday. Bye-bye.
Okay,
Love you,
thank
Mr.
you.
Clopton.
Bye.
Bye-bye.